I'm hoping to make this video quick. We're going to solve another trig equation, but I want you to notice the equation here. It says variables on both sides. We want to solve for the angle here that would make this equation true, and I only want the angle in degrees between 0 and 360. This equation here, recall that when you solve a trig equation, you have to isolate the trig function. We have both a sine theta on the left and on the right. So we are going to treat this much the same way we would treat something like this. If I had negative 3x minus 2 equals 7x minus 1, what we'd be doing is we would be moving some of the x's over to the other side to get them on one side and then isolating them. We're going to treat this the exact same way. So since I have a negative 3 sine theta and a positive 7 sine theta, I think it's more convenient to add the 3 sine theta to both sides and leave things in terms of positive. So we say plus 3 sine of theta, sorry about my 3 there, and then we're going to go ahead and say those cancel out. I'm left with negative 2 equals, well, how many total sine thetas? I've got 10 of these sines of theta, and this is minus 1. Okay, so now let's go ahead and isolate our trig function. I'm going to add 1 to both sides here, and I get this. I get 10 of these sines of theta equal negative 2 plus a positive 1 is a negative 1, and then we're going to divide both sides by 10. And so we end up with this expression, or this sentence right here: sine of theta equals negative 1/10. Now, to undo the sine, recall that we have to do the sine inverse to undo this. And we have to do it to both sides. So sine inverse of the left and sine inverse of the right. So those cancel out, and we're left with this finally. We say, if you put this on your paper, I cannot tell you you're wrong. As a matter of fact, the angle, let me try to write this a little bit more cleanly, a little cleaner. The angle is equal to the angle that when you take the sine of it, you get negative 1/10 for an answer. Now, one thing I want you to notice here is this. This is not a typical value. And by typical, what I mean is this. It's not like 1 over 2 or root 2 over 2 or root 3 over 2 or 1 or 0 or negative 1. So what we're going to need to do is we're going to need to use a calculator. And so what I mean by use a calculator is literally we're just going to pull out our calculator and say, what is the sine inverse of negative 1/10? So the first thing I'll do is this. We'll take a 1, make it negative, and then we'll divide that by 10, which of course is negative 0.1. And we'll do the sine inverse of negative 0.1. Now, my calculator's in degrees, and I want degrees. That's what it said, give me my answer in, but it says negative 5.74-ish degrees when I do the sine inverse of this. So what I'm going to tell you is this, negative 5.74-ish. I'm going to write that, negative 5.74 degrees-ish. And the thing I want to point out here is essentially this. This is not the actual angle. This is the reference angle. And I know what some people are watching here and thinking, oh, I thought reference angles couldn't be negative. Technically, this isn't a reference angle, but it is a reference angle. We're going to interpret this as being some positive 5.74. So I'm going to be very clear. We need to draw a picture of 4 angles that all, and I'm exaggerating here, this is way bigger than 5 degrees, but all 4 of these angles have a 5.74 degree reference angle, 5.74-ish degree reference angle. And I'll say all of these are the same, okay? So putting in this mnemonic here that tells us where our trig functions are positive at, I'm going to say, okay, well, I got sine inverse of negative 1/10. And so since sine came out to be negative, what this means is the quadrants we must be in is not 1 and 2, but 3 and 4. So we say, what are these 2 angles right here and here? And so we're going to have to use a calculator here, but this first angle we'd say it'd be 180 plus another 5.74. So I'm going to clear this out. We say 180 plus 5.74, of course, is 185.74. So we say one of our angles is 185.74 degrees-ish. And then the other angle, we said, well, it's 5.74 degrees shy of 360. So we'll take 360 and we'll take off this 5.74-ish. And we get about 354.26. So 354.26 degrees. And these would be easy to check by plugging back into the original equation, seeing you get a true statement. Cheers.